here we are gonna solve a numerical which is based on differential equations. So we are gonna get the solution of differential equation by the different methods of differential equation. Now the question that comes in the mind, that which method we must apply here to get the solution, because there are many methods to get the solution of differential equation. So guys, if you observe this equation carefully, then I can see that this equation is in the form m dx plus n dy equal to 0. And for such equations, if the value of dou m upon dou y is equal to dou n upon dou x, then we say that it is exact. So it means we can get the solution of this equation by using the method of exact differential equation. So let's check whether the value of dou m by dou y is equal to dou n by dou x or not. So for that, I'll say comparing the above differential equation with m dx plus n dy equal to 0. So by comparison, we'll get the value of m as 2xy raised to 4 e raised to y plus 2xy cube plus y, and the value of n equal to x square y raised to 4 e raised to y minus x square y square minus 3x. Now from m we can get the value of dou m upon dou y. So for that we have to partially differentiate m with respect to y. So this 2 and x is a constant, I'll take it outside, and for this y raised to 4 e raised to y, we'll use the UV rule. So here we will get e raised to y as it is. This will become 4y cube. So here we can say not 3 but 4y cube. Next, plus this y raised to 4 as it is, and e raised to y, the derivative will be e raised to y, plus 2x as it is, and the derivative of y cube is 3y square, plus the derivative of y with respect to y is 1. So here we will get 4 e raised to y cube into this 2x, that is 8x e raised to y cube. Next, here we will get plus 2x y raised to 4 e raised to y. This is plus 2 into 3, we can say that is 6, or we can say it in next step. Here I'll say it is 6x y square plus 1. Now let's find out the value of dou n by dou x. So dou n by dou x equal to, so here I'll differentiate n with respect to x partially. So y raised to 4 and e raised to y, they are constant, I am taking it outside, and for x square we will get derivative as 2x. Next here minus y square as it is, for x square we will get 2x and minus 3. Now guys, if you compare these two values, that is dou m by dou and dou n by dou x, they are not equal, and since they are not equal, the given differential equation is not exact. So here I'll say therefore dou m by dou y is not equal to dou n by dou x, and therefore the equation is not exact. So now it's sure that we cannot get the solution right now by using the method of exact differential equation. But the question is, can we reduce the given differential equation to exact to get the solution by exact? So the answer is yes. Now the question is how. So for that you have to understand the other methods of differential equation by which we can reduce it to exact. So guys, this is the method 1, where we say if the equation is in this form, that is f1 of xy y dx plus f2 of xy x dy equal to 0, then we can reduce it to exact by finding the integrating factor like this. So let's observe here. So from this equation if you see, then I can take y common and I'll get y dx here, and the remaining function, whatever is remaining the bracket, is my f1 of xy. Similarly, here I can take x common from the bracket, so I'll get x dy outside, and in the bracket whatever will remain is my f2 of x comma y equal to 0. It means I can represent my this equation in this form, and hence I can get the solution by this method. So let's represent it. So here I'll say, so guys, if you'll see these forms, and if our equation comes in this form like dou n upon dou x minus dou m upon dou y whole upon m equal to f of y, it means the value of this function, if we are getting it as a function of y, then we can say that the integrating factor is e raised to integration of f of y dy, and by getting the integrating factor we can multiply the given differential equation with the integrating factor to get the exact differential equation. So we'll check the results. So in the examination you have to check both the things, and if one of the thing or one of the pattern is matching with the given differential equation, then we have to use that pattern. So here I'll check this pattern number 4. So for that I'll subtract dou n by dou x and dou m by dou y. It means I'll subtract dou m by dou y from dou n by dou x. So here I'll say therefore dou n upon dou x minus dou m upon dou y whole upon m equal to. So guys, now let's check the answer. So here the value of dou n upon dou x is this minus this value. So you can observe that 2y raised to 4 e raised to y x minus this value. So here also we have 2x y raised to 4 e raised to y. So values are same. So if I'll subtract this value, then they are exactly same, so they will be cancelled. Next, minus 2xy square, and this will become negative. So minus 6xy square, that will become minus 8xy square. Next, minus 3 minus 1 will become minus 4, and now the only one term is remaining, so that will be minus 8 times x e raised to y into y cube upon value of m. So this is the value of m. I'll copy it down. So that is nothing but 2x y raised to 4 e raised to y plus 2xy cube plus y. Now guys, from the numerator we can take this minus 4 common, so we'll get minus 4 outside the bracket. Now from the last term we will get positive 2x e raised to y cube, since I have taken minus 4 outside. So you can check that minus 4 into 2 times this will be minus 8 times this. Next, this is second term. So from this also I have taken minus 4 outside, so plus 2xy square will remain in bracket, and since I have taken minus 4 outside, here I get positive 1 upon, from the denominator I will take y common, so in bracket we will get 2x e raised to y cube, because I have taken 1y outside, plus 2xy square plus 1. Now guys, we can cancel these two brackets which are same, and we got minus 4 upon y, which is nothing but function of y. So it means it is matching with the pattern number 4, and hence we can say that therefore the integrating factor equal to e raised to integration of f of y dy. So guys, this will give us e raised to integration of minus 4 upon y dy, and which is nothing but e raised to minus 4 outside, and the integration of 1 upon y is log y. So this will become e raised to log of y raised to minus 4, and then by the property e and log will be cancelled, so we will get answer as y raised to minus 4. So integrating factor is y raised to minus 4, or we can say it is 1 upon y raised to positive 4. So here we got the value of integrating factor. Now we can multiply the given differential equation with integrating factor to get the exact differential equation. So for that, I'll multiply this given differential equation with 1 upon y raised to 4. So let's see what we get. So for that, I'll write here that therefore multiplying given d with integrating factor to make it exact, differential equation. So guys, by multiplying with 1 upon y raised to 4, here we will get 2x e raised to y as the first term. Here 2x upon y plus 1 upon y cube. So plus 2x upon y plus 1 upon y cube into dx, plus from the second term we will get x square e raised to y minus x square upon y square. So x square e raised to y minus x square upon y square, and here minus 3x upon y raised to 4. So minus 3x upon y raised to 4 dy equal to 0. Now guys, this equation is exact. So now we can find the solution of exact differential equation by using the formula. So here this is the formula for the solution of exact differential equation, which says integration of m dx by treating y constant plus integration of n with respect to y by treating the terms which are free from x. So we will get, here I'll say its solution is given by integration of m dx. So 2x e raised to y plus 2x upon y plus 1 upon y cube into dx plus integration of n dy. So for this we should consider the terms which are free from x, that means the terms which does not have x. So if you see here the value of n, all terms has x, so we don't have any term, so I'll say it is 0 dy equal to c. Now let's integrate this term with respect to x by treating y constant. So we will get therefore 2 e raised to y outside since it is constant, and integration of x is x square upon 2 plus 1 upon y constant. Here we will get 2, that is also constant, and integration of x is again x square upon 2 plus 1 upon y cube constant, and integration of 1 with respect to x is x equal to c. So guys, here we can cancel this 2 and 2. So the answer is e raised to y x square plus this is x square upon y plus x upon y cube equal to c, and this is nothing but the solution of given differential equation. So I'm sure that you understood the concept and the numerical based on the exact differential equation, where we have reduced it by using the reduction method to exact differential equation. And if you want to learn more videos about engineering mathematics and the concept of the differential equation, then you can log into ekeeda.com today itself to get access to all videos at one place. So all the best. Thank you very much.